Hello everyone again and welcome to machine learning tips. Yesterday we did look at the different data types in machine learning. So today we'll be looking at what kind of operations we can perform on these different data types. So the first thing we'll be looking at what kind of things can we learn from numerical data type. So which the first things we'll be looking at will be what descriptive statistics. If descriptive statistics is we can look at the mean, the median, the mode, the variance, the standard deviation, the covariance, and the covariance matrix. The first thing we'll be looking at will be what like the mean. The mean is most of the times we call it like the average. It's like looking at the numerical average of what of any attribute. So we are terming it here numerical because we are looking at the operations we can perform on the numerical data. So the mean is like the sum of all the values in that numerical attribute. We divide by the what? By the total number of items. So if we have, let's say, a a numerical attribute that is made up of 7 elements, and then we sum all the 7 elements, we divide by what? By 7. So let's say we create a data frame here. We have seen how to import these NumPy as well as pandas. We create a data frame just to get data and to try to perform these operations. We run this. We have a data frame where we have like 3 columns, x1, x2, and x3. Let's say we want to calculate the mean for what? For column x2. So we have seen how we can extract columns in a data frame and all the like. So I'll just do df. I pass in the name of that column. I'll just do what? Dot mean. So dot mean here will calculate the mean of that column alone, which is what? 19 point something. So let's say if I want to change this and decide to go with the third column, I'm just going to have what? The mean as 5 point something. So that is how to get the mean. The next thing we are going to be looking at is what? The median and what? The mode. Median is like the median value of a sorted list. So if that sorted list, let's say we want to look at the median of this second column, x2. Now there are 7 elements in this sorted column. So the first thing we need to sort these elements first so that it appears from lowest to highest. And then from there, we can look at the median value. If the median value, there are 2 of them, definitely we are going to sum those 2 median values and divide by what? 2. So for the mode is like the value that occurs most often in in an attribute or feature. Let's say we want to look at the mode in x3. So x3 here, we look at those values. We can see here that 5.4 occurs twice. So the mode in that column will be what? 5.2, 5.4, please. So we have this list sorted. Let's say we first of all sort this list. We want to get the median for column x2. When we sort this list, we can see that there are 7 items. The median value here is what? 19. So let's see. If I do print, pass in that column, and I do dot median, it is going to give us what? 19. The same if I do with the case of the mode, because I'm trying to look at the index, I'm going to grab that index there as what? 5.4. So if I run this, I'm going to have the median as 19.0 and the mode as what? 5.4. Now, a common another descriptive statistic measure that we have is what? A measure of spread, which we call it what? The variance. Variance measures how spread out the average is from the what? From the mean. So what the variance looks at is the average square deviation from what? From that mean. So it takes every value in a column where you want to calculate that variance, and then you keep subtracting it from the mean. So meaning that before you calculate the variance, you need to first of all compute the mean for that attribute, and then you can go ahead. Let's say I want to compute just the variance from what? From that second column, as I did the last time. The mean was 19. So if I do x2 and I run this dot var, so we are going to have that variance as what? As 321 point something. So if you want to do it manually, meaning that you will have to like get that mean for that second column, and then you keep subtracting it from every other value, and then you take the sum, you divide by what? N minus 1. N minus n here will be the total number of items, which will be 7, minus 1, which will be what? 1 on 6, divided by the sum of the square deviation from what? From that mean. Now, where do we see this application? We will see how variance is very applicable in machine learning. Because we want to look at how spread a distribution is, then the variance is very, very important. Now, another common measure of spread is what? Is the standard deviation, which is like the square root of what? The variance. So if I want to get the standard deviation of, again, that second column, I'll just do x2. I pass in just to extract that column. I run this, and then I run I just do this, and then STD, and then it's going to give me what? The standard deviation, which is just like the square root. If I take the square root of this value, and then I'm going to have what? 17 point something. Now, another common thing that we'll see a lot, especially if we have a vector and we want to calculate the average of each of those features. Let's say here, in the first case, I was just looking at the average of a particular column. Here, I just say I did mention x2, you can do anything. I was looking at the average of a particular column. What more if I want to look at the average for each of these columns? That is when we talk of what? Multi-dimensional mean, which is like we are going to go through, is the same like calculating the mean, but we are going to look at the mean across all those data points. So if I run this, I'm going to get the mean for each of those features, like x1, x2. We already saw that for x2 it was 19 point something, and then for x3 it was 5 point something. You can see remove this axis is equals to 0. I think if you do same, you are going to have the same calculations here. So another measure that we are going to see here is what? The covariance. Covariance is also another measure of the spread, but we use the covariance a lot, especially when we are trying to look at the relationship between attribute or features in any data set or a data frame. So the covariance measures how far two attributes vary together. You know, the variance looks at just a single attribute, but if we want to look at how far two attributes vary together, that is what we are looking at, what we call what? The covariance. So this is the formula for the covariance, because it's looking how far two of those attributes vary together. You will see that the formula is similar to the variance formula, but because we are looking at two attributes, the square is no longer there. One thing you have to note here mathematically, if I convert this to like a single attribute, this and this will be the same. That is why we are having the square here. So if I run this covariance with these two attributes, it looks at the relationship between each of those attributes. Like if I want to look at how does x1 vary with x2, it will be what? 18 point something. If I look at how it varies x1 with x3, it will be what? Minus 0 point something. So that is how when we get this covariance, it is very essential, because we can use it a lot to do what? To calculate the correlation between two of those attributes. I did mention correlation yesterday. We are going to see this a lot, especially when we come to regression problems. Also, the covariance matrix is a table showing all the variances and what? And the covariances between all those features. If I run this, we are going to have something similar to this. It's almost the same. But if I want to do, this is very common when we will come to calculating what? The covariance of the relationship between maybe x1 and x2, maybe x3 and what? And x1 and so on. Now, when we get this covariance matrix, we can actually calculate the total variance between all these attributes. Now, one thing you have to note in this covariance matrix is that what? These diagonals, like this one, and this one, is actually what? The variance between each of these attributes. Like the variance of x1 will be what? 4 point something. The variance I did calculated for x2, it was 321 point something, and so on. So if I want to get the total variance for this covariance matrix, what I do is what? I'm going to sum these diagonals. So if I sum these diagonals, I'm going to have the total covariance, which is, if I run this, I should have 325 point something, which is like summing this, and what? And this. Now, the Pearson correlation coefficient is another very interesting statistical measure, where it's being used to measure what? The linear relationship between what? Between two variables. Because it's looking at the linear relationship between two variables, it is like going to be the standard deviation between those two variables divided by what? The standard deviation for each of them. So we already calculated the covariance matrix. Let's see how we can use this covariance matrix to calculate what? The correlation between two variables. There are two ways. It's either you can go using this covariance matrix if you want to calculate the relationship between x1 and x3. It will be the covariance between x1 and x2, which is 18 point something, divided by what? The square root of the variance of x1 multiplied by what? The square root of the variance of what? X2. Because we don't want to go through that mathematical concept, what we can do in Python is easy to do this. Because I have that data frame, I can just do df dot what? Dot COOR, and then I run this. If I run this, we are going to see that the correlation between a variable and itself will simply be what? 1. It will always be 1, because if you do the same here, it's like you are taking a value which is same. Because if I want to do this, it's like here. If I want to look at the relationship between this value and this one, it will be what? This divided by what? The square root of this multiplied by the square root of this value, which will always be what? It will always be 1. Now, the relationship between x1 and x2, if I use this, go through this formula calculation, the value will be what? 0.5, which as we go into measuring correlation between two variables, anything which is always above 0.5, we always say that there is some moderate correlation between those two attributes. Now, if we look at x1 and x3, we are having a minus value. Please, one thing you should note here is that this minus value is just showing direction. Now, the direction here will simply mean that when one of these attributes is increasing, the other one is decreasing. It doesn't mean that there is a negative correlation between them. So that is how to interpret this. Guys, that was it for this lesson today. Tomorrow we are going to be looking at what? Normalization, how to scale values, especially when it comes to some machine learning algorithms like the K-means algorithm that is very sensitive to outliers. So thank you very much, guys. See you tomorrow.